Hello there and welcome to a brand new lesson. This is Hub Beyond Numbers where we learn maths the easy way. In this lesson, we are looking at mapping diagrams and then function rules. These are lesson objectives. Without much ado, let's look into it. So when we talk of mapping diagrams, a mapping diagram is simply a visual way to show how elements of the domain are mapped to the range. Most of the time to use arrow to show the direction of the relationship. So let's say we have a rule that says multiply by 3 and then add 1. If you have to multiply by 3 and then add 1 and we want to use arrows, that is the mapping diagram, then if our domain is going to be, let's say, 1, a 2, and then a 3, then if we have to multiply 1 by 3 and add 1, that gives us a 4. You have to multiply 2 by 3, that is 6, and add 1, we have a 7. Then 3 times 3 plus 1 also gives us a 10. So as I said, we need to use arrows. So using arrows to show the relationship, this is how it is going to be. Now, apart from this method, there are also input and then output tables as well. So the input and output table is a more organized way to use the pattern. So talking of the input and output table, comparing it to the mapping diagram, we would say it is a more organized way to see the pattern. It helps us spot the relationship between our input, which is the X, and then our output, which is the Y. So for this same set of values we had, if we were to use our input-output table, then all we would have done was to create a table in this form. And then in the first row, we put our input. So we just write input, and then in the second one, we have our output. Then in the input section, we have 1, then 2, and then the 3. Then in the output, we have our 3, 5, and then 7. Very, very simple, as you see. So the input being our X. So I'll put the X here. And then for the output, we put our Y as well in a bracket. So these are the two methods we'll be seeing in the course of our lesson and then in our subsequent lessons. So now that we have this, let's go to our next session. In our next session, we want to talk about linear mapping rules. When we say a function or mapping is linear, then we are trying to say it is of the form f of x being equal to an ax and then plus a b. So since you are in school, most of the functions you'll be looking at will be of this form. It will be linear. Now, the a you have in some books as well, you might even see it as f of x being equal to the mx plus c. The most important thing is you have your x, and with the x, there is a variable multiplying it. It could be a, it could be m, what have you. And your b or the c in this case is always the adjustment, what you want to add or subtract after multiplying. So we say the a or the m is simply the multiplier. So the a or the m, depending on the book you are using, is the multiplier. Then your b and the c will then be the constant you add or subtract. You see, this is all linear function is about. If the function follows this form, then it is linear. With that said, let's look at some examples of some functions, and then by method of observation, we see if we can determine the rules of these functions. So with this first question, it says using the method of observation, determine the rule for the mapping. Now the mapping is as shown on our table, And we have 1 mapping toward 4, 2 maps to 7, and 3 maps to 10. Before we can say for sure that it's a linear mapping, then we need to determine whether or not there is a constant difference between our output values. And by constant difference, I mean we look for the difference between the subsequent values. That is 10 minus 7. Is the answer the same as 7 minus 4? That is, if you take this preceding number and then find the difference between these two, is it the same as looking for the difference between this and this? If it is, then we can proceed with a method we want to use. 10 minus 7, it gives us a 3. And 7 minus 4 also gives us a 3. That alone should tell us that yes, the table here follows a linear mapping. Now with that, we then have to guess the rule. So after getting your constant difference, that is you being able to determine all of this, you come and say f of x is equal to the constant difference you have here, which is our 3. Then you multiply it by your input, x. And then in your mind, you try and then make adjustments, either a plus or minus. So if you pick x to be 1, then we substitute it in here. 3 times 1 gives us what? 3. Now the 3, we have plus what gives us a 4. Or minus what gives us a 4. It is certainly a plus. So it is a plus 1 that gives us a 4. If it is a plus 1, then there's no need keeping this subtraction here. Now let's continue with the subsequent and see if this same value or this same rule is going to work. So for 2, we have 2 times 3, that gives us a 6. 6 plus 1 also gives us a 7. Let's try for the last one. 3 times 3 gives us a 9. Then the 9 plus 1 gives us a 10. And with that, you realize that if we test for all the values, it works for our rule. Hence, this here is our rule. As simple as that. So it simply means each and every input value is related to the output by what? 3x plus 1. And that is our rule. As simple as that. Let's take some few more examples. So in this second example, it says we have to use the method of observation once again to determine the rule for the mapping we have here. What do we have as our input? So we have 1, 2, 3, 4, and then 5. And then as our output, we have -1, and then a 1, a 3, a 5, and 7. So we need to first of all identify what type of function is it, or a mapping that it is. Is it linear? There is another one we call the exponential, but for the scope of this lesson, we are looking at the linear. For the linear, 7, that is the difference between the subsequent values should be equal. That is to say, 7 minus 5 should be equal to 5 minus 3, and should be equal to the 3 minus 1, and it should be equal to the 1 minus -1. Where am I taking all this from? So 7 minus 5 should be equal to 5 minus 3, should be equal to 3 minus 1, and then it should be equal to 1 minus -1. You don't necessarily have to do all, but because I'm explaining, I just want to show you that they should all be equal. And true, they are all equal, and they are all equal to what? 2. So since the constant difference is the same, then that constant difference we have, we would say our f of x is equal to this 2 here times our input variable, which is x. Then we now make our adjustment. So 2 times x, let's say if x is equal to 1, we are going to get 2 times 1, and 2 times 1 gives us a 2. What do we need to do to 2 to get a -1? That will be to subtract 3 from it. So with that, let's settle with 2x minus 3. And then let's continue with the subsequent input to see if it will satisfy our guess rule here. So for f equals, let's take the very big one, which is 5. You can take any of them. So we have 2 times 5. 2 times 5 gives us a 10. And a 10 minus 3 gives us a 7. That also satisfies. So there is even no need continuing to test again. So this is just to tell you that the rule f of x equals 2x minus 3 is the rule for the table we have over here. And this is correct. So with all this that we have done, then we can generalize the rule on how to determine we can generalize the steps on how to determine the rule of a mapping using the method of observation. And that will be very, very important in the exercises I'm about to give. So with respect to all that we have done then, we would say to identify the function rule, first of all, check how the output changes when the input increases. We do that to be able to tell if it is a linear function or not. After which you then look for the multiplier. So the multiplier is the difference we have been looking for. By how much is each output increasing with respect to the input. Then after that, you do adjustments to find the constant that is being added or that is being subtracted. And with that, you are good to go. Now, it is important that you don't assume all rules are the same. So you need to solve each and every question uniquely. We'll end this lesson here, and as usual, I'll give you some exercises so you try your hands on them. So here are 3 questions you can try on your own just to test your understanding. For the very first one, you have to draw a mapping diagram for what you have here. The mapping diagram, I would want you to draw that of the arrow and then the table. Then secondly, you have to complete this table. To complete this table here simply means you need to find the rule, after which you use the rule to find the missing piece. And then for the last one, you have just to find the rule for this function you have over here. We are ending this lesson here. Let's have beyond numbers where we learn maths the easy way. See you in our next lesson. If this is your first time on this channel and you think it would be of help to you, you can choose to subscribe. If you so do, so that anytime I release a video, you'll be notified as well. See you in our next lesson, and bye for now.